Question. DS. X and y are positive integers. When 2 times 10 to the power of x plus y is divided by 3, what is the remainder? Condition 1, x equals 2. Condition 2, y equals 4. Solution. Let us solve this DS question using the variable approach. The remainder after a division by 3 or 9. The remainder after a division by 3 or 9 is the same as the remainder after dividing the sum of the digits of that number by 3 or 9. Let's apply the 3 steps of variable approach. Let us follow the first step of the variable approach by modifying and rechecking the original condition and the question. We are required to find the remainder when 2 times 10 to the power of x plus y is divided by 3 if x and y are positive integers. Now let us modify the question based on the property we have learned above. Let us find what happens when we expand the term 2 times 10 to the power of x. The term will always be 20, 200, 2000, and so on. That is 2 followed by zeros depending on the value of x. When we add the digits together, we get 2 plus 0 plus and so on until we get plus 0 equals 2. That is, the sum of the digits of 2 times 10 to the power of x is always 2. Therefore, we need to check the divisibility of 2 plus y by 3. So we have to find the value of y. Wow, this shows the standard approach to solve a DS question. Thus, let us look at condition 2, which tells us that y equals 4. Then, the remainder, when 2 plus y equals 2 plus 4, that is 6, is divided by 3 will be 0. This condition has a unique answer, so this condition is sufficient by CMT2, which states that the number of answers must be 1. Condition 1 tells us that x equals 2. However, we still cannot determine a unique value of y. If y equals 1, then 2 times 10 to the power of x plus y equals 2 times 10 to the power of 2 plus 1, which equals 2 times 100 plus 1, plus 200 plus 1, which equals 201, which has 0 as its remainder since 2 plus 0 plus 1 equals 3, and 3 equals 3 times 1 plus 0. And if y equals 2, then 2 times 10 to the power of x plus y equals 2 times 10 to the power of 2 plus 2 equals 2 times 100 plus 2, which equals 200 plus 2 equals 202, which has 1 as its remainder since 2 plus 0 plus 2 equals 4, and 4 equals 3 times 1 plus 1. So, this condition is not sufficient by CMT2, which states that the number of answers must be 1. This is an integer question at the 50 to 51 level. Condition 2 alone is sufficient. Thus, B is the correct answer. Okay, you can get a score of 50 to 51 in GMAT math if you have the opportunity to solve these levels of questions. Answer B.